The graph of f of x equals sine x is shown at right. For our warm-up, let's estimate the slopes for the graph of f of x at sine x. And you may already know what the derivative of sine x is, so you might have a prediction here. What is the slope at negative 2 pi? That looks like it's about 1. The slope at negative 3 pi halves is 0. At negative pi, looks like about negative 1. Then 0, positive 1, 0, negative 1, 0, 1. This graph, hey, we know what that is. That is cosine. So f prime of x, or the derivative of sine x, is cosine x. We learned these derivatives in Unit 3, so just as a reminder, here are your trig derivatives. The derivative of cosine u is negative sine u, u prime. So our derivative is negative 6x times sine 3x squared. I can rewrite this as a power where I have tangent of 5x to the power of 4. So I'm going to need to use the general power rule. First, we will pop down and power down, leaving the inside function the same. And then we'll multiply by the derivative of the inside function. The derivative of tangent 5x is secant squared u, which would be 5x, times u prime, 5. Multiply 4 and 5. And we have our answer. The derivative of cosecant u is negative cosecant u times cotangent u times u prime. Number 4 will require the product rule. The derivative of cotangent x is negative cosecant squared x. The derivative of e to the negative 2x would be e to the negative 2x times negative 2. If you were asked to factor this, you could factor negative e to the 2x out. For example 5, without a calculator, find the slope of the graph of y equals 3 cosine negative x, where x is pi halves and where x is negative pi thirds. You may remember that cosine of negative x is equal to cosine of x, because cosine is an even function. You could still do this problem without changing it, knowing the even identity, but I'm going to use the even identity so I don't have to deal with all the extra negatives. That makes our derivative negative 3 sine x. Let's plug in our x value of pi halves to find the slope at pi halves. The y value at pi halves is 1. So when x equals pi halves, the slope of y equals 3 cosine negative x is negative 3. To plug in negative pi thirds, remember that negative pi thirds is coterminal to 5 pi thirds. So the y value at 5 pi thirds is negative root 3 over 2. Now we're going to evaluate a limit. If I eyeball this direct substitution, I think we're going to get 0 over 0, an indeterminate form. But if we're going to do that, if we're going to use Lhopitals Rule, then we need to show that the limits of the numerator and denominator separately are the same. They are both 0, making this limit after direct substitution 0 over 0. That's an indeterminate form. If you get an indeterminate form for a limit of a fraction, then you can use Lhopitals Rule. We're going to derive the numerator, derive the denominator, and then take the limit of that new fraction. The derivative of tangent u is secant squared u prime. U prime would just be 1. Now I think we can evaluate the limit of the numerator's derivative over the denominator's derivative without getting an indeterminate form. Remember that secant is the reciprocal identity to cosine, so cosine of 0 is 1, which means secant of 0 is 1, and 1 squared is 1.
Find the x values of the relative extrema for the function f of x equals sine x minus cosine x on the interval 0 to 2 pi.
Let's begin by deriving. Now we're going to find critical numbers. There are no times when cosine x plus sine x is undefined because cosine x is defined for all x's and so is sine x. So the sum of the two is also defined for all x's. There are two ways you could solve this, but first I'm going to move the sine and cosine to opposite sides of the equation. Now you could square both sides and use Pythagorean identities, but then at the end you would need to check for extraneous solutions. So instead of doing that, I'm going to divide both sides by cosine x. Negative sine x over cosine x is now equal to 1. I didn't lose any variables, so I didn't lose any answers, but negative sine x over cosine x is equivalent to negative tangent x. Let's get that negative back over to this side, so tangent x is now equal to negative 1. And that's the equation we're solving to find our critical numbers. Tangent of theta is y over x, so where is y over x equal to negative 1? That would be at the angles 3 pi fourths and 7 pi fourths. To check if these angles give us relative extrema, let's create an f prime number line. They did give us an interval, but they asked for relative extrema, so we don't need to check the endpoints. So we have a relative min at x equals 7 pi over 4, and a relative max at x equals 3 pi over 4 on the interval 0 to 2 pi.